Okay, now the question is 35. Structure Q in the following reaction. So in this case, if we draw the mechanism of the compound or the reaction, that is C triple bond N, here we can see that phenyl pH MgBr. So in case of this Grignard reagent, Mg is delta plus and it should be delta minus. Similarly, in case of Cn, carbon is delta plus and nitrogen is delta minus. So the attack of the phenyl to the carbon of the Cn group is occurring, and it should be like this. C, there is pH, so there will be one double bond N minus, and it should be combined with MgBr. So this is Mg plus. So this should be NMgBr. Okay. Now after the hydrolysis, if we hydrolysis with H3 plus, then it gives the product C double bond O pH like this. So the answer will be option B. B will be the correct answer for this question. Okay. Question is 23. The end product of the following reaction. This is benzene diazonium salt N2 plus Cl. In presence of CuKCN, it converted to Cn. Okay, it converted to Cn. After hydrolysis, Cn, it converted to benzoic acid like COOH. So if we add NaOH with calcium oxide, this is called soda lime, then removal of CO2 take place and we get a benzene ring, that is an arene. So the correct answer will be option D. Specify the configuration E or Z of the following compound. Here we can see that these are the two compounds of the double bonded compound. If we write the numbering, here you can see that in case of these two groups CH3 and NH2, NH3 will be 1 or it will be 2, okay, according to priority order. Similarly for H and CH3, it 1 and it 2, that is higher priority groups are on the same side of this double bond, same side of this double bond. So this is Z configuration. Okay, so this is Z configuration. Similarly, in case of this compound 2, if we numbering this side pH or D, pH should be 1 according to CIP rule. Okay, and in this case COH should be 1, that is more priority, more higher group. So these two higher groups are opposite of this double bond, so opposite to this double bond, that's why it is E configuration. So the correct answer will be option C. Okay. The question is 54. Which compound is nucleophile? So as we know that LCl3 is a electrophile compound and it is act as a Lewis acid. Okay, it act as a Lewis acid. BF3 is also a Lewis acid because its structure is like this, BF3. Okay, similarly LCl3. But in case of NH3, the structure is pyramidal shape, is tetrahedral structure. It has also lone pair which donates to the other molecule. That's why it is nucleophile. And CH3Cl is also an electrophile. So the correct answer will be C. Hydrazobenzene can be obtained by reducing nitrobenzene with. So the answer will be zinc NOH. Hydrazobenzene, this means when it's formed, the structure will be like this. This is hydrazobenzene. So that's why if we get this product, so we should add zinc plus NOH in nitrobenzene reducing in nitrobenzene reduction. Okay, so the answer will be D. Question is the correct order of acidic strength of the given compound. Trichloroacetic acid, trichloro-CCl3 COOH, this is trichloroacetic. Trifluoroacetic acid, CF3 COOH, and acetic acid and formic acid. So between this, we know that the trifluoroacetic acid is more acidic than trichloroacetic acid because fluorine has more electronegativity. That's why it attracts electron density towards itself, and see, that's why the OH electron density in these OH bonds becomes weak and it can easily donate H plus. That's why its acidity will be higher than CCl3COH. So 2 will be more acidic than 1. So 2 greater than 1, this is not wrong, this is not wrong, this can be answer, but the correct answer will be C, because acetic acid, formic acid, between formic acid and acetic acid, obviously acetic acid has less acidic than formic acid. So the acidity of formic acid is higher. That's why correct answer will be option C. Okay, correct answer will be option C. In SN1 reaction, chiral starting compound always gives. Chiral starting compound always gives. As we know that in the reaction mechanism for SN1 reaction, there will be a formation of carbocation. So carbocation means there will be a p orbital. So there will be a possibility of a racemic mixture. Racemic mixture, that means 50% S and 50% R product is formed. 50% S configuration and 50% R configuration is formed, because nucleophile can attack from this side as well as from this side also. Okay, that's why we can get 50% S and 50% R configuration. So we can get racemic mixture in case of SN1 reaction. Answer will be option B. Number 78, here we can see that this is an elimination reaction, because we get 2 alkene product, but the question is the reaction take place by which rule, the product is formed by which rule. So it should be Hofmann, because here we can see that the compound is a charged compound. That means if the substrate is, if there is a presence of charge in the substrate, then it should be the major product should be according to the Hofmann rules. Okay, that's why OH minus can abstract a proton from this side. If we draw one hydrogen atom, okay, here we can write CH3 CH bond H CH, and this is leaving group NMe3, and this is CH2. So OH minus can abstract a proton from this side. Here double bond is formed and this group is removed, and we get this product as a major product. Similarly, OH minus can also attract a proton from this side, and we can get this product also. So it follow Hofmann elimination rules, because it is a charged substrate. So that's in case of charged substrate, Hofmann rules is follows. So option C will be the correct answer. Dash is an essential amino acid. It is very easy. It is lysine. Lysine should be is an essential amino acid. Among these, the achiral amino acid is glycine, because glycine structure of the glycine is NH2 CH2 COOH. So this compound is achiral. The only amino acid which is achiral is glycine. Okay. Arrange the correct order of stability of the following radical. So CH3 radical, as we know that radical is also electrodeficient molecule like carbocation. So CH3, and there is RCH2 dot, RCHR dot, and RCR dot. If you consider, generally R is considered as an alkyl group, so there will be if there will be more R, that means there more conjugation, that means hyperconjugation. So if we considering hyperconjugation or plus I effect of the alkyl group, then the stability of the 4 will be higher and stability of the 1 will be lower. And similarly 4, 3, 2, 1. So the right answer will be 4, 3, 2, 1. Option A. Option A will be the correct answer. Paracetamol is simply N-acetyl para-aminophenol. N-acetyl. This is acetyl group. Para-aminophenol. N-acetyl para-aminophenol. This is N-acetyl para-aminophenol. There should be one H. Okay, para-aminophenol. Reagent is used to identify propene. Which reagent is used to identify propene and propyne? So to identify the double bond or triple bond, that means to test or distinguish this unsaturation in a compound, we should use ammonical silver nitrate, not Br2CCl4. It should be ammonical AgNO3. Okay, to distinguish propene and propyne. Okay, to distinguish propene, distinguish between propene and propyne. Propene and propyne, if we distinguish, then it should be ammonical AgNO3. Okay, ammonical AgNO3.